Welcome back. Today we're going to be talking about scale factor and similar figures. Our content objective is students will be able to find the side length, perimeter, and the area of similar figures. Language objective is students will be able to explain how to find the scale factor of similar figures. And why am I learning this? Well, it's important for many real-life examples, such as finding the height of something that's difficult to measure, like the height of a tree. So what are similar figures? Well, they're figures that have the same shape but not the same size. So you can think of it as being one is a blown up version of the other. So let's take a look at these two. So these shapes are identical. However, one is a bigger version of the other. Okay, so these are similar figures. And a scale factor is the ratio of any two corresponding lengths in two similar figures. So this height of 50 corresponds to this height here of 100, and this length of 100 corresponds to this length of 200. So what is the scale factor mapping the left rectangle to the right rectangle? Well, going from 50 to 100, I would go ahead and say it's 2, because this length is twice as much. Okay, so you can think of it as, hey, 50 times 2 is what gave us 100. Now, if I ask a different question, such as what is the scale factor mapping from the right rectangle to the left rectangle, now that would not be 2. So this way, I'm actually thinking of how is 100 becoming 50? Well, I took half of it. So for that reason, I would say the scale factor is 1/2. Now, some of you are going to want to say, oh, okay, well, you just take 100 and divide it by 2. But you can't have a scale factor be divided by 2. So you would express that scale factor as 1/2 instead of dividing by 2. So hopefully you see here 100 times 1/2 is 50. You could even see 200 times 1/2 is also 100. So there's two ways to go about this problem. You can refer to finding the scale factor from the small to the large, or from the large to the small. So I'm going to go from the smaller rectangle to the larger rectangle, which means the scale factor is going to be a number greater than 1. Why? Because the shape is getting larger. So that's important to keep in mind. So I'm thinking that 18 times the scale factor, I'm just going to go ahead and use the letter S because it reminds me of scale factor. So 18 times a scale factor S is going to give me 72. So I'm going to divide both sides by 18. And if you divide this, you're going to get a 4. So what does this mean? From the small rectangle to the large rectangle, it's getting 4 times larger, which means this height of 7 will also get 4 times larger, which would make x 28. So here I would say the missing length is 28. However, is there another way to go about this? Yes. I went from the smaller rectangle to the larger rectangle, and that's why my scale factor was greater than 1, because the shape was getting larger. But if I went from the larger rectangle to the smaller rectangle, then my scale factor is going to be less than 1 because the shape is getting smaller. So we could have reversed it and say, okay, 72 times what scale factor? S is going to give me 18. So if you divide both sides by 72, instead of saying that it was 4 times as large, going this direction, it would be 1/4 the length in this case. So here, if you multiply this by 1/4, you would have gotten 18. And here, you would have to multiply x by 1/4. Let's do it like this. And that would have given you 7. And if you solved it, x times 1/4 equals 7. That's basically x over 4 equals 7. Multiply both sides by 4, and x equals 28. So no matter how you solve it, you're going to get the same answer as long as you're doing the steps correctly. Now obviously, since x was on this side, it is easier to move in this direction, but understand that it works both ways. So quick recap, going from the scale factor of left to right, I would say the scale factor was 4. Why? Because the shape was getting larger, so it's definitely going to be bigger than 1. But if they ask me what is the scale scale factor mapping from the right to the left, because the shape got smaller, it would be 1/4. Now looking at the ratios, if you compare the small rectangle to the large rectangle, you will see the length of the smaller rectangle is 18, the length of the larger rectangle is 72, and that's going to be equivalent to the height of the smaller rectangle, which is 7, and of course the larger rectangle, which we just found, is 28. If you reduce these, they will all reduce to 1/4. So here, find the missing side. Why don't you go ahead and pause the video and try this one by yourself. Okay, so here, if we want to find the scale factor, first you can think of it as going from the smaller rectangle to the larger rectangle. I will go ahead and show both. So here, I'm thinking of 6 times a scale factor, which I'm going to call S, is going to give me 18. If I divide both sides by 6, I'm going to be left with the scale factor is 3. That means 6 times 3 gives me the height of 18, which means X times 3 will give me the length of 24. Some of you could probably solve this in your head and say that it's 8. However, if you didn't, I would just go ahead and solve this like this by dividing both sides by 3, and I'm left with X equals 8. So notice, going from left to right, going from the smaller rectangle to the larger rectangle, the scale factor is 3, which makes sense because, again, the shape is getting larger. Now, if I wanted to go the reverse of going right to left, then I notice the shape is getting smaller. So anticipate a scale factor less than 1. So here you're thinking of it as, hey, 18 times a scale factor is going to give me 6. So I'm going to say 18 times a scale factor is going to give me 6. Divide both sides by 18. And I'm left with S equals 1/3, which means 8 times 1/3 gave me 6, which should mean 24 times the scale factor of 1/3 should give me X. So to solve for X, you would do 24 times 1/3, and that would give you 8. So again, it really doesn't matter which way you go, you're still going to get the same answer, but please understand, depending on which direction you're moving, the scale factor should coincide with the size. So for example, if the shape is getting larger, it's going to be greater than 1. If the shape is getting smaller, your scale factor is going to be less than 1. So quick recap, the scale factor going from left to right, since it was getting bigger, it was 3. However, the scale factor from moving right to left, since it's getting smaller, it was 1/3. So if you look at our ratios from the small to the large rectangle, you're going to find that these are proportional. If you reduce both of these, you do end up with 1/3. Now, please understand, if I did flip this around and say the large rectangle over small rectangle, then we would get 3 if we reduce it, which coincides with the scale factors that we found earlier. Number 3 says find the missing side. So it tells us triangle ABC is similar to triangle DEF. This is important. I'm not going to be able to use a scale factor unless I know the shapes are similar. So first of all, I have a huge tip for you. Please keep in mind that it's going to be best to move towards the direction of the variable. So for that reason, I'm going to go from the larger triangle to the smaller triangle. Now, keeping in mind, since the shape is getting smaller, I'm going to anticipate the scale factor being less than 1. So keep that in mind. So here, I'm thinking of 12 times a scale factor, let's call it S, is going to give me 10. So I'm going to go ahead and solve for this scale factor, and that's going to give me S equals 10/12. But I notice I can divide both by 2, so I'm going to go ahead and do that, which is going to give me 5/6, which means 12 times 5/6 is going to give me 10. That means 8 times 5/6 should give me X. So I'm going to go ahead and solve. 8 times 5/6 is going to give me X. I'm going to go ahead and cross cancel. I notice 8 and 6 have a 2 in common. So we're going to be left with 20/3 is going to equal X, which if you need to, you can go ahead and turn it into a mixed number. You don't really have to, but if you did turn it into a mixed number, it would be, let's see, 20 divided by 3 goes in 6 times. So I would say it's 6 2/3. Both of these are equivalent, so both are right. Now, if we were to look at the ratios from the size of the large triangle to the small triangle, then we would compare the 12 to the 10, and then the 8 to the, which we just figured out, x is 6 2/3. Now, what if they asked you what is the scale factor from the from the large triangle to the small triangle? Again, keep in mind, because it's comparing the larger to the smaller, you're thinking of it as, hey, the size is getting smaller, so I do anticipate a scale factor less than 1, which was 5/6. Now, if they went the opposite direction, which would mean they were asking the small triangle to the right triangle, your scale factor would be different. It would have been 6/5. So it is important which direction they're asking you to figure out the scale factor for. Okay, so for number 4, why don't you pause the video and try number 4 by yourself to figure out what n is. Okay, so let's see how well we did. Again, since n is on the right side, we should best be moving in this direction. It would make things a little bit easier for you. Okay, so first I'm going to start with the sides I know. So I'm going to compare 2 to 41. Let's use a different color here. 2 to 41, which means 2 times a scale factor is going to give me 41. So if you divide both sides by 2, you're going to be left with the scale factor is 41 halves. This means that 2 times 41 halves gives us 41, which would mean 6 times 41 halves is going to give us n. So I'm going to go ahead and solve for n by doing 16 times 41 halves is n. I'm going to go ahead and cross cancel. I notice we can divide by 2. I'm going to have to do some side work. 41 times 8, that's 8, and 32. So we're going to get 328 equals n. So that is the missing length. Number 5 says draw a rectangle with side lengths twice as long as the image and label the new vertices E, F, G, and H. So first it's important to know the original length so that we can actually double it, since they are asking it for it to be twice as long. So here it's 1, 2, 3, 4, 5, 6, 7. And here the height is 1, 2, 3, 4, 5. So since this is 7 and this is 5, now the new length is going to be twice as much, which would make it 14, and this height would be twice as tall, and which would make it 10. So I'm going to go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the length now is going to be 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now that I have that, that would be our new shape. And I would go ahead and label it E, F, G, and H. And I can prove it to you because this here is 14 and this is 10. Number 6 says draw a rectangle with side lengths half as long as this image and label the new vertices E, F, G, H. Go ahead and pause the video and try this one by yourself. Okay, so let's see how well we did. So first, it's going to be a good idea to go ahead and identify the original length and height. I would say the length is 10 and the height is 16. Since they are asking us to take half of it, I'm going to go ahead and multiply it by a half, which means the new length is going to be 5 and the new height is going to be 8. So here's a rectangle with a height of 8 and the length of 5. And let's go ahead and label it E, F, G. H. Don't forget about H. Okay, so what is the scale factor from left to right? So here, hopefully you see that the size is getting smaller, specifically getting half as small. Now, the hint here was they did ask us to find half, so it makes sense the scale factor is a half. But if you wanted to check the ratios, here's a tricky part. We don't go from left to right. We actually go from right to left so that we do get a value less than 1 since the shape was getting smaller. So I think that's going to be the trickiest part when they ask you to find the scale factor from left to right. You're going to be tempted to write a ratio using the left to the right corresponding sides, when in actuality they are the reversed. So notice here, I went from right of 5 to the left of 10 to give me my scale factor of a half. So number 7, it says draw a rectangle with side lengths 3 times as long as the image and label the vertices E, F, G, H. I keep forgetting the H. So first and foremost, it's important to label the lengths. So right now, the length is 7 and the height is 3.5. So the new length is going to be 21 because we're going to multiply it by 3 because that's what 3 times means. And 3.5 the height by 3 as well. And what did we get? We have a new length of 21, which is right here, and a new height. Well, if we do 3.5 by 3, we would get 10.5. So hopefully you see that here. Here's a 21 by 10.5. And the vertices are labeled. So what is the scale factor from left to right? So here, once again, it's important to first understand they asked us to make it 3 times larger, so of course it's going to be 3. But if they didn't tell us that and we were just looking at an image, what's tricky is if they're asking us to go from left to right, we can see here the value is getting, the shape is getting bigger, so we're expecting a scale factor greater than 1. And so when you check the ratios, you'd actually be moving from right to left. So 21 over 7, which is 3. Or 10.5 over 3.5, which is also 3. Number 8, draw a rectangle with side lengths 4 times as long as this image and label the new vertices E, F, G, H. Go ahead and pause the video and try this one by yourself. So first, it's important to understand the dimensions that we currently have, which is 2.5 by 3. So since they're asking us to do it 4 times as much, we're going to do 2.5 times 4 and 3 times 4, which is going to give us 10 and 12. So that is the shape we're going to create, a 10 by 12. And we're going to label it E, F, G, H. So what is the scale factor from right to left? Here, they're actually trying to be tricky. They're going the opposite of what we've been doing. So here, from right to left. Hopefully you recognize the scale factor is going to be less than 1. Why? Because the shape is getting smaller. So the tricky part is to remember, even though they're asking us from right to left, when we check our corresponding sides, we're moving the opposite direction because we're going from 2.5 to 10 and we're going from 3 to 12, which would give us a scale factor of 1/4. Now that does kind of relate back to the instructions here, which says 4 times. Now that's if we were going from left to right, but because we're going the reverse, it ended up being the reciprocal, which is 1/4. Number 9, draw a rectangle with sides 1/3 as long as this image and label the new vertices E, F, G, H. So we have a 15 by 9, so if we take 1/3 of both sides, we're going to end up with a new shape that is going to be a 5 by 3. So that is our new shape, our E, F, G, H. And if they asked us what is the scale factor from right to left, first I would want to understand, if I'm going from right to left, that the shape is getting larger. So I'm expecting a scale factor to be greater than 1. So for that reason, when I look at my corresponding sides, I am going to put the larger value on top, which would be 15 corresponds to 5, which ends up being 3, or 9 corresponds to 3, which also turns into 3. Now, some of you may be confused because you might be thinking, wait, they asked us to take 1/3 of it, so why is it 3? Because they specifically asked us to go from right to left. Well, that actually concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye!